So in this video, we're just going to go through the steps of calculating area and average value of a function. So for e to the negative 2x, if our interval is negative 1 to 3, if we wanted to get an integral to calculate the exact area, our limits would be negative 1 to the 3 of e to the negative 2x dx. Now in calculating the average value, it's very similar, except we have to divide by the length of the interval, so 1/4. Now where's the 4 coming from? 3 minus negative 1 gives me 4. So that's 1 over b minus a, basically. Then from negative 1 to 3, e to the negative 2x dx. Now we're going to calculate these using a graphing calculator. And there's a couple different ways that you'll see this done. I'll just show you one of them. Here I've got another video somewhere that shows you another way. So the negative 2x. And now if we want to calculate this definite integral from 1 to 3, we'll graph it. And we're not that concerned with what the graph looks like on this particular instance. We go to second, calculate. Number 7 there is a definite integral, and we're doing it from negative 1 to 3, and that's the definite integral. So this one we know is approximately 3.6933. Now if we wanted to do the average value, we could take that number and divide it by 4, or if you wanted to do it the same way we just did it, what we could do is multiply that by 1/4, regraph it, and then we'll calculate this guy from negative 1 to 3. And so this one is approximately 0.9233. Now, if we're given the antiderivative of that function, we can actually also use the fundamental theorem to get the exact value. Let's say we're doing part A, then the integral from negative 1 to 3 of e to the negative 2x dx. Because we have an antiderivative, negative 1/2 e to the negative 2x, we're going to go from negative 1 to 3, and plugging these in, we're going to get negative 1/2 e to the negative 2 times 3. Let's do parentheses out here instead of writing negative 1/2 twice. And e to the minus 2 times negative 1. So the exact value we could write as negative 1/2 times e to the negative 6th minus e squared. And we could even go ahead and double check, verify this with our calculator. We know what the answer should be. So if we get out of the graph, let's move this over to this side, it's a little more light, and we're going to do negative 1/2 times e to the negative 6 minus e squared. Oh, I have a parenthesis in the wrong place, sorry. I needed to close that around my negative 6. It's kind of nice when we already know what the answer should be. When you make a mistake, it makes it a little easier to find. And there we go. Confirmation of our answer from before.